so I'm going to take you guys through looking at your uncertainty, because this is definitely something I've seen a lot of issues with. So this student, they took a food, they weighed it, and they did a titration, and I'm going to talk you through the steps with that. So first thing they did is they got a balance and they measured out 100 grams. I'm not going to put units in at this point, although I would when I then transfer it to a table, but just to make my life easier, I'm going to leave it without units. So they measured out 100, and this was to the nearest 0.1 gram. In fact, actually, if I put units here, that should work. The next is that they then measured out, so they used 100 cubic centimetre measuring cylinder. I showed you on the last video how to do superscript, so I'll leave it for you to work it out there. Again, that's a measurement of 100, and the equipment uncertainty was 1 cubic centimetre. So they weighed it out, they boiled the food in water, and they did that at a particular temperature. So we're going to use our thermometer, and we're going to go for when they did 80 degrees. So the equipment uncertainty for that was 0.5. Okay, could do a column for units as well, just to make life a little bit easier. So they heated it, they would have used a stopwatch, they heated it for 10 minutes, so that's 600 seconds. Please convert into seconds, because it's not a decimal. If you can't just do 0.1 divided by 1 minute, because the 0.1 will be in seconds and the 1 will be in minutes, and it just doesn't work. Okay, so convert into seconds, and the equipment uncertainty I'm going to say is 1 second, although the stop clock went to more decimal places. Someone's reaction speed, in fact, it's probably a bit more than 1 second really, if you think about the time it actually takes to kind of stop and start. So maybe 2 seconds, but 1 second's fine. What do they do next? So they boiled their food, they blended it up, and then they took a 25 cubic centimetre sample using a pipette. Now, I'm not completely sure I've remembered this correctly, but I'm pretty sure it's about 0.08 for a 25 pipette. And then they titrated. You can assume any solutions you got from the technician have no uncertainty, although that's not true. If you make it yourself, you'd need to use the uncertainty on the balance and the volumetric flask. And then we had a burette. Now, the measurement for 80 degrees, we got 27.2. And the equipment uncertainty, that is 0.1. I'm using the tighter, so we're doubling that equipment uncertainty. Okay, so I think that is everything for this one. You are going to have to think through, because quite often students will just go for these last two for the actual titration and not think about everything that would affect it. Because if we think through, if the student had measured up 200 grams and dissolved that in 100 cubic centimetres, that potentially would have twice as much vitamin C. If that solution had been 1,000 cubic centimetres instead of 100, the vitamin C would be 10 times more dilute. The time for cooking would impact, which is why the cooking was a control factor. Okay, so go through and make sure you have included everything. So work out, the reason why I haven't put units on is so I can use my spreadsheet to do the calculations for me, and that's going to be equipment uncertainty divided by measurement. And I can bring this back down here. Okay, now each of these you can see a different number of decimal places, but the uncertainty of the equipment is always 1 sig fig. So you're going to have to go through more way and make all of these 1 significant figure. Okay, I haven't worked out a way of doing this without just kind of clicking through. This one is going to be that. The previous one times 100 to get my percentage. And just got to do the same thing again. Okay, right, so here at the bottom I'm going to do a total. To calculate the total, it's equal sum. Select all of these, 2.5, and again once it's down to one significant figure, 2.5. Oh, I guess it must have rounded up to 2.5, but the actual one is less than so if I do more significant figures, you'll see it's just under 2.5. That's why it's rounding down to 2 instead of rounding up. Okay, so my total percentage uncertainty is 2%. That is pretty low, which means that this experiment will be quite precise. Okay, so percentage uncertainty is talking about our precision. In my evaluation, if I was looking at ways of improving precision, you should easily be able to see that here the measuring cylinder is the point where I had the least precision, followed by thermometer. There's no point making this more accurate using a balance to 3 decimal places. There's no point doing that because this percentage uncertainty is such a small fraction, it's actually negligible. Okay, whereas these two are fairly significant. Okay. If you had a very small titer, you might find that this is quite significant as well, so you'd look at ways of having a bigger titer. So here, ideally, the student maybe would use a volumetric flask and measure out their 100 cubic centimetres to try and increase their precision. Okay, now what that means is you will have to do this for each of your averages. There's only 5, so it's not that bad. Some of these are not going to change. So your control variables will always be the same. So these ones I've put on the X control variables, you're only actually going to have to work out the relative uncertainty for these two and then add it to the sum of the others. So these are the only two that are going to change. Okay, you only have to do a sample. You don't and then just give us the total at the end for each of them. So on your final set of data, which I've not calculated for this, you're going to want a column for percentage uncertainty or total relative uncertainty, and then you need to convert it back to absolute. Okay, so I've reordered this. I've put the 2 at the bottom that will change. And then these are the other uncertainties that are effectively fixed. Okay, so these ones at the top that aren't going to change, give me this total. I am just going to copy that and paste that as a value. Okay, so that's the uncertainty, not including temperature and titer. Okay, so in here, and this isn't necessarily what I'm going to stick in the spreadsheet. What I had before would be fine. Here I've calculated, this is actually the mass per 100 in milligrams per 100 grams. So that's the mass of vitamin C. So I just calculated that. I paused and calculated it. Might make it slightly clearer. Okay, milligrams per 100 grams. I'm just going to merge and wrap. There we go. Okay. So this is the uncertainty that's going to be the same. It's these 4 that are the same every time. And then I need to work out the percentage uncertainty for the 2 that are going to change. or fractional. It's okay to do fractional as well. Merge that. There we go. Okay, so for each of these it's going to equal 0.5 divided by this. Drag that down. Oh, it's not percentage yet, is it? So times 100. So there we go. There we go. That's our uncertainty. See, we can see for temperature, percentage uncertainty is really high for 20 degrees and much lower for 100. Okay, because obviously our measurement's getting bigger. And here it's going to be 0.1. Actually, I'm going to times that by 100. So 10 divided by that. So it is fine just to do fractional uncertainty. I think I'm just in a habit of doing percentage. Okay, so I'm going to make all of these one significant figure. So, but in reality they aren't. That's just how it's displayed. And then my total percentage uncertainty is going to be this value plus these two. Okay, so I'm actually going to just type it in. Plus this plus this. Yeah, that's okay. So do that, scroll that down, and we can see we've got a little bit of change. I think it's easiest to just, because I can see they're all one hot, there we go, whole number. Okay, so that's my percentage uncertainty, or my total percentage uncertainty. Let's merge and wrap again, and then I need to do my absolute. So having done it in a percentage, I now need to convert back into the units that it's in. So this is going to be milligrams per 100 grams of the food. And let's just merge and wrap again. There we go. So to do this, I need to find 4% of this. So which is why it might just be easier to stick to fractional, if I'm honest. But it's also fine to do that. Okay, there we go. So these are my absolute uncertainties. These absolute uncertainties have come from this total percentage uncertainty, which is to the nearest whole number. So only one significant figure. This also needs to be only one significant figure. So I'm going to convert them to a number, and I'm going to say 0 decimal places. That's a bit quicker. You can do that if they're all to the kind of same number of decimal places. Right. So what that means is my absolute uncertainty is kind of 6 or 8 milligrams per 100 grams. I cannot quote my mass of vitamin C per 100 grams to the nearest, in this case, what, 0.0001 gram. So all of these also need to be to the nearest whole number. Okay, remember, our values cannot be more precise than our data. There we go. Okay, so this is now what we should be seeing for a set of process data. Okay, things to watch out for is that all your uncertainties are to one significant figure, and that the precision of your final value matches your absolute uncertainty. Okay, hopefully that is helpful. Take care.